Okay, let's just dive right into it. If you're going to work with data in any way, shape, or form, you have to speak its language. And today, we're going to learn the absolute fundamental grammar, the different variable types that are the building blocks for every single analysis you'll ever do. You've probably heard this quote a million times. And you know what? It's totally true. Data is this incredibly valuable resource that fuels, well, pretty much everything now. Business, science, technology, it's the raw material for all the big ideas. And we are absolutely swimming in it. Every single day, we, humanity, generate about 2.5 quintillion bytes of this stuff. I mean, that's a number with 18 zeros after it. It's just an amount of information that's almost impossible to wrap your head around.
So just like crude oil, raw data is kind of useless until you understand what it is and how to process it. So how do you take that massive flood of information and turn it into something valuable? Well, the very first step is learning how to sort it out.
Here's the good news. Every single piece of data you will ever encounter belongs to one of two fundamental families. And getting this first split is the key to everything else. On one side, you've got qualitative data. Think qualities, descriptions, labels. This is the stuff that answers why or what kind. And on the other side, you have quantitative data. Think quantities. This is all the numerical stuff that answers questions like how many or how much.
So let's start with that first world, the world of descriptions. Qualitative data is all about categorizing our world, using words and labels to create groups, and just bring some order to all the non-numerical info out there.
The most basic ground floor level is nominal data. And its Latin root, nomen, is a dead giveaway. It means name. So it's all about names. Nominal data just sorts things into different buckets. But those buckets have no natural order. One isn't bigger or better than another.
So let's look at some real examples. Eye color, car brands, marital status, these are all just labels, right? We can count how many people have brown eyes, sure, but the category brown itself doesn't rank higher than blue. They're just different, distinct categories.
And this question just illustrates the whole point perfectly. You can find the most common hair color, which is called the mode, but you can't do math on the labels themselves. I mean, what's brown plus blonde divided by 2? It's nonsense.
But what if our categories do have some kind of logical sequence? Let's level up from just naming things and introduce a new superpower, rank.
And that brings us to ordinal data. It's still about categories, but now the categories have a meaningful order. But here's the crucial catch. While you know the order, you don't know the exact distance between the ranks.
A customer satisfaction survey is the absolute classic example. You know that satisfied is better than neutral, and very satisfied is better still. The order makes perfect sense. But is the jump in happiness from neutral to satisfied the exact same size as the jump from satisfied to very satisfied? We have no idea. We can't assume the intervals are equal. All right, let's hop over to the other world, the world of numbers. Quantitative data is all about stuff we can either count or measure, and this is where we can really start to unleash some powerful statistical tools.
First up in this world is discrete data. The key word here, the one to remember, is counted. These are values that are distinct and separate. You can't have half of one. Think whole numbers. There are these clear, finite steps between each value.
Just think about it. The number of students in a classroom, or the number of cars in a parking lot. You can have 30 students or 31 students, but you can't have 30.5 students. The values are distinct, countable things. Now for the other kind of numerical data, continuous. So if discrete data is counted, continuous data is measured. It can take on any value within a range, and how precise it is just depends on how good our measuring tool is. Think about height or weight or temperature. Someone's height isn't just 180 or 181 centimeters. It could be 180.5 or 180.52 or even more precise than that. The values exist on a smooth, unbroken scale. So, we've sorted our data into these different buckets. Why on earth does this matter? Well, it matters because knowing the data type is like knowing the rules of the game. It tells you exactly what you can do with your data, and maybe even more importantly, what you absolutely cannot do. And this table here, it just lays out that whole game plan perfectly. Think of it like a ladder. Down at the bottom, with nominal data, you can really only classify things. Take a step up to ordinal, and now you can put them in order. Now, the next two rungs, interval and ratio, they're both types of quantitative data. Interval data, like temperature in Celsius, has equal steps. The gap between 10 and 20 degrees is the same as 20 to 30, but it doesn't have a true zero. 0 degrees Celsius isn't no temperature. But ratio data, like your weight, has both equal steps and a true zero. 0 kilograms means no weight. And because of that true zero, you can do all the math like multiplication and division. Every step you climb up this ladder unlocks more and more powerful analysis.
And these rules, they directly tell you which tools to pull out of your toolbox. If you use the wrong statistical test or the wrong kind of chart for your data type, you could end up with conclusions that are completely and utterly wrong. For example, a bar chart is absolutely perfect for ordinal data like education level. You can show the counts for each category, and because you've ordered the bars, it tells the story. You can see the distribution across a meaningful spectrum. But for nominal data, like market share for different car brands, there's no natural order. So here, a donut chart or a pie chart works great. It's not about rank, it's all about showing what slice of the pie each category gets. It's about proportion.
And by understanding this simple framework, you've honestly just gained a data superpower. You can now look at any data set and immediately know the first, most critical steps to handling it the right way. So here's the bottom line. Classifying your variables isn't some boring academic thing you have to do. It is the practical, foundational step that makes sure your entire analysis is sound. It's what separates a pile of meaningless numbers from a powerful, accurate, and compelling data story. So you had the keys now. You know how to unlock the language of data. You know its grammar, you know its rules. The only question left is, what are you going to use it to discover?